Space is a vast and mysterious place. Among its wonders are the planets and their moons, dancing around their parent stars in a cosmic ballet. Our solar system is home to a wide array of these celestial bodies, each unique and fascinating. Jupiter, the largest planet, reigns supreme with its impressive entourage of moons. Among them is a small enigmatic moon named Hermippe, shrouded in mystery. Hermippe holds clues to the formation and evolution of planetary systems. Scientists use telescopes and spacecraft to unlock these secrets. Join us as we journey to the outer solar system to explore Hermippe. Let's uncover the mysteries this small but captivating moon holds. Jupiter's moon system is a microcosm of the solar system. With over 90 moons, it showcases immense scale and diversity. The four largest, the Galilean moons, are worlds unto themselves. Beyond these giants lies a fascinating collection of smaller moons. Among them is Hermippe, a member of the Pasiphae group, suggesting a common origin. These moons are believed to be fragments of a larger body captured by Jupiter's gravity. Discovered in 2001 by Scott S. Shepard's team, Hermippe is a relatively new addition to our understanding of Jupiter's moon system. Initially designated as S2001J3, it was later named Hermippe, after a figure from Greek mythology. Hermippe's discovery highlighted the ever-evolving nature of our understanding of the cosmos. As technology advances, we continue to find new celestial objects, pushing the boundaries of our knowledge. Hermippe's discovery serves as a reminder that there is still much to explore in our universe. Each new discovery brings us closer to unraveling the mysteries of the cosmos. Hermippe is a small, faint moon, a mere speck of light, even through powerful telescopes. Its diameter is estimated to be about 4 kilometers, making it one of the smaller members of Jupiter's moon family. Located about 21 million kilometers from Jupiter, Hermippe is a distant world. Despite its small size and remote location, Hermippe helps us understand the dynamics of planetary systems. By studying moons like Hermippe, scientists can piece together the gravitational interactions that have shaped the Jovian system. These interactions have left their mark on the orbits of Jupiter's moons, creating a delicate balance. Hermippe takes approximately 629 Earth days to orbit Jupiter. Its long orbital period is due to its immense distance from the gas giant. Hermippe's orbit is retrograde, meaning it orbits Jupiter in the opposite direction to the planet's rotation. This characteristic is shared by many of Jupiter's outer moons, suggesting a common origin. Hermippe's orbit is also highly eccentric, causing its distance from Jupiter to vary. This fluctuating distance subjects the moon to varying degrees of tidal stress. Hermippe is likely composed primarily of rock and ice, similar to other small outer moons. Its surface is thought to be heavily cratered, bearing the scars of billions of years of impacts. Due to its distance from the Sun, Hermippe's surface is incredibly cold. This extreme cold would preserve any volatile compounds, such as water ice. Scientists believe Hermippe is likely dark and reddish in appearance, similar to other Jovian moons in the Pasiphae group. This coloration is thought to be due to the presence of organic molecules. Hermippe holds a significant place in our understanding of the cosmos. Its unique characteristics offer valuable insights into the early solar system's formation. Hermippe's retrograde orbit and high inclination suggest a capture origin. This capture event likely occurred during a chaotic period in the early solar system's history. By studying captured moons like Hermippe, scientists can piece together the events of this tumultuous era. Analyzing their orbits and compositions allows scientists to reconstruct the original parent body. Hermippe, a small and icy world, measures a mere 4 kilometers in diameter. Despite its diminutive size, Hermippe holds a certain allure for astronomers and planetary scientists. Its surface area, a mere 50 square kilometers, could fit within a small country on Earth. Hermippe's surface is believed to be remarkably diverse, sculpted by a constant barrage of micrometeoroids. Telescopic observations suggest a world pockmarked with craters, a testament to its long history. Each crater whispers tales of ancient collisions in the cold depths of space. Hermippe's surface is likely a desolate yet captivating landscape. Craters of all sizes dominate the landscape, each telling a tale of a violent encounter. Interspersed between the craters, vast plains of regolith stretch towards the horizon. This regolith is likely rich in minerals and organic compounds. Beneath the surface lies the possibility of water ice mixed with rock and other volatile compounds. The presence of water ice would make Hermippe a potential target for future exploration. Hermippe's distance from the sun dictates a realm of perpetual twilight. Sunlight bathes the moon in a faint ethereal glow, casting long shadows across the cratered landscape. The play of light and shadow on Hermippe's surface is a mesmerizing dance. The angle of sunlight varies dramatically throughout Hermippe's long year, resulting in extreme temperature variations. This creates a hostile yet strangely beautiful environment. Hermippe's surface is a testament to the enduring power of nature. The exact composition of Hermippe remains a subject of scientific inquiry. Based on its orbital characteristics, scientists believe Hermippe is most likely a C-type asteroid. These materials are remnants from the early solar system, containing primordial ices and organic compounds. The presence of carbonaceous materials could explain Hermippe's low albedo. Further observations are needed to confirm Hermippe's composition and search for other materials. The discovery of water ice would indicate a potentially valuable resource for future space exploration. Hermippe holds a special place in our understanding of the cosmos. Its unique characteristics provide valuable insights into the processes that shaped the early solar system. By studying small, captured moons like Hermippe, scientists can piece together the history of giant planet migration. These interactions have played a crucial role in the evolution of our solar system. Hermippe's story is a reminder that even the smallest of worlds can hold profound secrets. Each new discovery brings us closer to unraveling the mysteries of the universe. Hermippe, a small and distant member of Jupiter's moon system, may seem insignificant. However, this tiny moon holds clues to a grand cosmic narrative. Scientists study Hermippe and its fellow outer moons to piece together the events that transpired during the solar system's turbulent youth. These outer moons, often irregular in shape and with eccentric orbits, are believed to be remnants of a time when the giant planets were still migrating through the protoplanetary disk. Hermippe's retrograde orbit is a telltale sign of its capture origin. The retrograde orbit of Hermippe presents a fascinating puzzle for astronomers. It is a celestial dance that seems to defy the natural order, a cosmic ballet where the dancers move in opposite directions. Understanding how Hermippe and its fellow retrograde moons came to be in such peculiar orbits is a key to unlocking the secrets of planetary system formation. One prevailing theory suggests that these moons were not originally part of Jupiter's system, but were instead captured from the surrounding protoplanetary disk. As Jupiter migrated through the disk, its immense gravity acted as a cosmic net, drawing in smaller bodies and altering their trajectories. However, capturing a body into a stable retrograde orbit is no easy feat. It requires a precise combination of factors, including the approaching body's trajectory, velocity, and the gravitational influence of other nearby objects. The fact that Jupiter possesses so many retrograde moons suggests that such captures were not uncommon in the early solar system, a testament to the chaotic and dynamic nature of that era. Another theory proposes that these retrograde moons were once part of a larger body, perhaps a dwarf planet or a large asteroid, that was shattered in a catastrophic collision. The fragments from this collision, now represented by the individual moons, were then captured by Jupiter's gravity. The capture of a moon into a stable orbit is a complex and fascinating process, a celestial ballet governed by the laws of gravity. To understand how Hermippe and its fellow retrograde moons came to be part of Jupiter's entourage, scientists developed sophisticated computer models that simulate the gravitational interactions between these bodies over billions of years. These models take into account a multitude of factors, including the masses and velocities of the interacting bodies, their initial trajectories, and the gravitational influence of other nearby objects. By adjusting these parameters and running countless simulations, scientists can recreate the conditions that led to the capture of these moons and gain insights into the early solar system's dynamic environment. One key factor in capturing a moon is the presence of a mechanism to dissipate the captured body's energy. If a body approaches a planet too quickly, it will simply be deflected by the planet's gravity and flung back out into space. However, if there is a way to slow the body down, perhaps through gravitational interactions with other nearby objects or through tidal forces, it can lose enough energy to become trapped in orbit. The capture of Hermippe and the other retrograde moons likely involved a combination of these factors, a delicate interplay of gravity, velocity, and chance encounters that ultimately led to the formation of this unique and intriguing moon system. Hermippe, despite its small size, holds great potential for future exploration. Advanced spacecraft could unlock Hermippe's secrets, shedding light on the early solar system's history. Key objectives include determining its composition and studying its geology. Analyzing light reflections could reveal minerals and ices. A lander could collect samples, searching for organic molecules. Studying Hermippe's geology and surface features is crucial. High-resolution images could reveal its bombardment history. A lander could study the properties of its regolith. Investigating water ice beneath its surface is essential. Water ice could support future human exploration. Hermippe is a tantalizing target for future exploration, a small world with the potential to unlock big secrets. Among giants, a matter of scale. Hermippe, in the context of Jupiter's diverse family of moons, stands as a humble member, particularly when compared to the four colossal Galilean moons, Io, Europa, Ganymede, and Callisto. These behemoths, each a world unto itself, dwarf Hermippe in both size and gravitational influence. Ganymede, the largest moon in our solar system, could comfortably contain Hermippe within a small region of its vast cratered plains. While the Galilean moons command attention with their active volcanoes, subsurface oceans, and potential for harboring life, Hermippe offers a different perspective on the Jovian system. Its small size and irregular shape hint at a tumultuous past, shaped by capture and collision, a stark contrast to the more stately formation of the Galilean moons within Jupiter's primordial disk. This comparison highlights the incredible diversity of Jupiter's moon system, a microcosm of the solar system itself. From colossal worlds with their own geological processes to small captured bodies like Hermippe, each moon tells a unique story, contributing to our understanding of planetary system formation and evolution. Hermippe's significance lies not in its size, but in its potential to unlock secrets about the early solar system. Its capture, origin, and membership in the Pasiphae group make it a valuable target for studying the dynamics of planetary migration and the processes that shaped the outer regions of our solar system. Orbital dynamics, a celestial ballet of extremes. Hermippe's retrograde orbit sets it apart from the majority of Jupiter's moons, including the Galilean satellites. while the Galilean moons gracefully waltz around Jupiter in prograde orbits, moving in the same direction as the planet's rotation. Hermippe takes a more rebellious path, circling the gas giant in the opposite direction. This difference in orbital direction is a key indicator of their contrasting origins. The Galilean moons, with their prograde orbits and relatively low eccentricities, likely formed from the same disk of material that coalesced to create Jupiter. In contrast, Hermippe's retrograde orbit and high eccentricity point towards a capture origin, a celestial dance that began far from Jupiter's influence. Furthermore, Hermippe's orbit is significantly more elliptical than those of the Galilean moons. While the Galileans follow relatively circular paths around Jupiter, Hermippe's eccentric orbit takes it on a much more elongated journey, swinging closer to and farther from the gas giant over the course of its orbital period. This difference in orbital stability reflects the contrasting gravitational forces at play. The Galilean moons, locked in a delicate balance with Jupiter's massive gravitational pull, maintain their relatively stable, circular orbits. Hermippe, on the other hand, constantly experiences variations in Jupiter's gravitational tug throughout its eccentric journey, contributing to its more dynamic and less predictable orbital dance. Section 3. Compositional clues. Tracing origins and relationships. While the Galilean moons exhibit a range of compositions, from the volcanic sulfurous surface of Io to the ice-rich crust of Europa, Hermippe's composition remains largely unknown. However, its membership in the Pasiphae group provides some tantalizing clues. The Pasiphae group, named after its largest member, is a collection of retrograde moons that share similar orbital characteristics, suggesting a common origin. These moons are believed to be remnants of a larger parent body, perhaps an asteroid or a dwarf planet, that was captured and subsequently shattered by Jupiter's gravity. If Hermippe does indeed share a common origin with the other members of the Pasiphae group, its composition likely reflects that of its parent body, providing insights into the composition of objects present in the early solar system beyond the orbit of Jupiter. Future observations using spectroscopy could help determine Hermippe's surface composition, revealing the presence of minerals, ices, and possibly even organic molecules. These findings would not only illuminate Hermippe's own history, but also provide valuable data points for understanding the composition of the early solar system and the building blocks from which planets and moons formed. Section 4. Potential for discovery awaiting our gaze. Hermippe, despite its small size and distance, beckons with the allure of the unknown. Unlike the well-studied Galilean moons, Hermippe remains largely unexplored, its secrets hidden beneath a veil of distance and faintness. Future missions with advanced telescopes could reveal Hermippe's surface in unprecedented detail. High-resolution images could map its craters, revealing its history. Spectroscopic analysis could determine its surface composition. Hermippe awaits its moment in the spotlight, ready to reveal its secrets. Section 1. A Universe of Small Wonders. In the grand cosmic tapestry, small celestial objects like Hermippe hold profound insights. They are remnants of our solar system's chaotic birth. Studying these objects reveals the universe's secrets. Each crater on Hermippe tells tales of ancient collisions. Its orbit hints at gravitational interactions. The universe is a place of endless wonder and discovery. Even the smallest objects hold profound secrets. Section 2. Hermippe Beckons. Hermippe, with its enigmatic past and unexplored surface, stands as a beacon for future exploration. As we develop ever more advanced telescopes and spacecraft, the possibility of unlocking Hermippe's secrets becomes increasingly tangible. Missions to this distant moon, equipped with sophisticated instruments, could unveil a treasure trove of scientific knowledge. Imagine high-resolution images revealing the intricate details of Hermippe's cratered landscape, providing a glimpse into its bombardment history and offering clues about the early solar system's dynamical environment. Spectroscopic analysis of its surface could identify the composition of its rocks and ices, shedding light on its formation and evolution, and potentially revealing the presence of organic molecules. Perhaps most tantalizing is the prospect of a future mission landing on Hermippe's surface, deploying a rover to explore its alien terrain and collect samples for analysis. Such a mission, though ambitious, would mark a significant milestone in our exploration of the Jovian system, providing invaluable insights into the nature of captured moons and the processes that shaped the outer solar system. Hermippe Beckons, a small world with big secrets waiting to be uncovered. As we stand on the cusp of a new era of space exploration, with its promise of technological advancements and bold missions, Hermippe's allure only grows stronger. It is a reminder that the quest to understand our place in the cosmos is an ongoing journey, and that even the smallest of worlds can hold the keys to unlocking profound truths about our universe.